Alright, let's look at the homework 6.4, problem number 10. Alright, so let's do this water tank problem. Alright, so first thing we would do is I need to have a frame of reference. So I'm going to put the axis. So here, I'll just put x-axis here. Alright, and probably right axis through the middle, something like that. Alright, then here, this is our x-axis, and that's y-axis, and that's the origin. Alright, then let's see, radius is 6, which is right here. So radius is 6, so I'm going to label those. Alright, 6 is right here, and it's probably 6 here, and this is 2, so this is going to be 8 right there. Alright, so the length of the spout is 2. Alright, so what we're going to do is we're going to slice it perpendicular to the y-axis, and I'm going to just draw one approximating cylinder. So it's going to probably look like this. Alright. So this is the approximating cylinder. So I'm going to say that's going to be at the yi. Right, we can use yi star, but I'll just use yi. Alright, and at this point, we need to express the volume of this approximating cylinder. To do that, we have to know the equation. Alright, so here, this is, you can think of it as circle. So circle centered at the origin. So x squared plus y squared is equal to, alright, 6 is the radius, so 6 squared would be 36. Alright, then I'm going to solve for x. Alright, so I'm going to just solve this equation for x. So subtract the y squared from both sides, so you have x squared is equal to 36 minus y squared. Alright, then I'm going to take the square root of both sides, so you have x is equal to plus or minus square root of 36 minus y squared. Alright, so the right side, right semicircle is going to have an equation x equals square root of 36 minus y squared. Alright, so if you want to find the radius of this cross section, right here. So let's see, I'm going to use maybe a different color here. Alright, so here, from here to there, alright, and that radius is going to be, so this is going to be radius I. It's a square root of 36 minus yi squared. Alright, so let's find the volume of this thing. Alright, so volume of this approximating cylinder, we have to find the cross-sectional area, which is going to be a disk. So it's going to be pi r squared. So pi r squared. And the width is going to be, as usual, delta y. So which is going to be pi, and r is now square root of 36 minus yi squared. Then you have a squared, because you have r squared, and delta y. Right? And luckily, we can cancel those guys to get pi times 36 minus yi squared delta y. Alright, so that will be the volume of that approximating cylinder. Alright, so once you have a volume, we can find the mass. Right? In order to find the mass, all you have to do is density, which is 1000, and then multiply by volume that we just found. So it's going to be a pi 36 minus yi squared delta y. Right? That's going to be the mass. And then we can turn it into a force. Force is mass times acceleration. So you just have to do mi times g, right? So g is 9.8. So I'm going to just incorporate it with 1,000. So you have a 98,000 pi and 36 minus yi squared delta y. Right? So that's the force. Right? Then if you want to find the work required that approximating cylinder full of water out of the tank, what you need to do is you need to lift it, right, from yi to 8, which means that you're going to have to multiply by that distance, 8 minus yi. So what we're going to do is take the force and multiply by the distance you need to travel, right? But we know that, so this is going to be the force. I'm going to just write that out, right? And then we just have to multiply by the distance it needs to travel. So it's going to be 8 minus yi. Right? So that'll be the work. So if you want to find the total work for the entire tank, all you have to do is we just have to sum it up. I goes from 1 to n, and so we just write 9,800 pi and 36 minus yi squared, and multiply by 8 minus yi delta y. Right? Then to make it more accurate, I'm going to take the limit. Right? So once you can do that, you can just turn this into an integral. So it's going to be an integral. Right? Then you have, actually, I'm going to probably put the 9,800 pi outside since it's just a number. And the integral is going to go from, right, so the very bottom is -6. And up here is +6. So it's going to be -6 to +6. All right, then you have 36 minus y squared. I'm going to stripping off I. Then multiply by 8 minus y. Delta y becomes dy. All right. All right, let's evaluate this. So I'm going to go ahead and multiply out and see what you get. So you have a 9,800 pi integral from -6 to 6. All right, so you multiply 36 and 8. All right, so for 6 times 8 is 48. And 3 times 8 is 24, so 288. Right, then you have, let's see, so I'm going to do 36 times 8, so 36, so -36y. Right, then you're going to be -8y squared, and then plus y cubed. Right, then with respect to y. Right, so I'm going to use this trick. So since you're going from -6 to +6, all the odd function is going to give you a 0. So actually, since this term right here is an odd function, so you can scratch that out because it's going to produce 0 anyway. And a y cubed is also an odd function, so we get rid of that. Then what we can do is you just have an odd even function, so we can just write it as, all right, so instead of going from -6 to +6, I'm going to do halfway and multiply by 2. So it's going to be 2 times that, so it's going to be pi there, 0, 0. 2 times 8 is going to be 16, and 2 times 9 is 18, so you have 19,600 pi. All right, then we have antiderivative of 288 would be 288 y, right, minus 8 times y cubed over 3. Then you're just going from 0 to 6. Alright, so what you get is 19,600 pi. Alright, so you just plug in 6. Alright, so 6 times 8 is 48. And the 6 times 8 is another 48, so it's going to be 52. And the 6 times 2 is going to be 12, so it's going to be 1728 minus, right, 8 times and over 3. Alright, you have 6 cubed. Alright, 6 cubed is what? 36. So 36 times 6. 36 and 18, so 216. So 216. Alright, then we can cancel out. So it's a 3 and 216 cancel out. So that would be 72. Alright, so what you get is going to be, it's kind of a big number, let's say 19,600 pi. Alright, then you have, let's say 1728 minus, alright, so let's see, 2 times 8 is 16, and the 7 times 8 is 56, so 57. Alright, so you get 19,600 pi times, let's say 8 minus 6 is 2, and 12 minus 7 would be 5, and then it's going to be 6 minus 5 is 1, and we have that. Alright, so what you're going to get is, I'm going to cheat a little bit here. I'm going to just open up GeoGebra or calculator. I'm going to just open up a GeoGebra here. Alright, so I'm just too lazy, so it's going to be 19,600 multiplied by 1152. Alright, and then hit enter. Alright, so we got that. So 225762. So this is going to be 22576200. Is that it? 225792. Sorry, 9200. All right, and pi. All right, so let's type it in. All right, 22579200, and then pi. All right, so let's submit for testing. All right, it came back, and it's a terrible number, but it came out correctly. All right, that's it. I hope that this was clear.